Okay, Seema, this is the first question in Archimedes principle. Okay, so a piece of metal weighs 45 Newton in air and 28.5 Newton when it is fully immersed in water. So we are supposed to find out the specific gravity of the metal. Okay, ma? Can you say first of all what is meant by specific gravity? Specific gravity means what? Specific, correct only, na? Specific gravity. Specific gravity is nothing but relative density, ma. Okay? Another name for relative density is specific gravity. Okay? So what is meant by relative density? So density of any body compared to density of water. This is called as relative density. Are you able to understand? So this relative density I am supposed to calculate by the given data. Okay? It means the density of body divided by density of water. So can you say how can I calculate? Okay. See, my piece of metal weighs 45 newtons means what? It is the weight of the body, no ma? So, or you can say this is the actual weight of the body. Actual weight of body. So, actual weight of the body is how much, ma? 45. Weight formula mg only, no? Weight formula mg. Mass can be written as density into volume into g. Mass density into volume only, no? So, rho Vg is nothing but 45. And what is meant by rho here? Density of what? Density of body. Weight of body only, no, we are taking. So this is the density of the body. Clear, no? So density of the body is rho Vg, which is equals to 45 Newton. Clear, no? And when it is immersed in water, it is weighing only 28.5 Newton. Can you say what is the meaning of it? When it is immersed in water, it is weighing only 28.5. What do you understand by this? No, it is fully immersed in water. Actual weight is 45, but when it is immersed in water, its weight is 28.5. What do you understand? No. Anybody? Sima. When this body, it is fully immersed in water, completely immersed in water, then on this body, two forces will be acting, no ma? What are the two forces which are acting? So, one is its own weight, W, this weight, own weight, actual weight, that is acting, no? And if any body is present in a fluid, body always experiences a upward force. And what is the name of that upward force? Force of buoyancy. Already we studied yesterday, no? So, this body is experiencing a upward force which is called as force of buoyancy. So, weight minus a force of buoyancy is called what? Okay, ma? Actual weight of the body minus a force of buoyancy, this is called as apparent weight of the body. Okay? In ray optics study only we studied apparent weight, apparent depth, real depth, all this we have studied, no? So actual weight minus a force of buoyancy is called apparent weight. So what is meant by apparent weight? The weight which now we are feeling inside water. Okay, ma? Actual weight is 45 Newton. But when it is immersed in water, its weight is only apparent weight. Because when it is immersed in water, force of buoyancy is also acting. Are you able to understand? So therefore, what is the actual weight of the body? Actual weight of the body is 45. Force of buoyancy is how much? I don't know. But apparent weight I know, no? So this weight is called as apparent weight. Are you able to understand? Weight of the body when body is present inside water. That is called as apparent weight. Are you able to understand? So apparent weight is 28.5 Newton. Are you able to understand? So this is the actual weight when it is in air, and this is the weight of the body when it is immersed in water. Okay. So therefore, what is the force of buoyancy? Force of buoyancy is nothing but 45 minus 28.5. This is the force of buoyancy. Are you able to understand? So 48 minus 28 is how much, ma? 17, huh? 16.5 I think. Correct? Correct only, no? 16.5. Correct only, no, ma? 20, 30, 30. This is 30. 8 plus 4 is 14. That's all. 16.5 Newton. This is the force of buoyancy. Are you able to understand? So once I calculate the force of buoyancy, already we have a formula for force of buoyancy. No? What is the formula for force of buoyancy? Force of buoyancy is rho L VL G. This is the force of buoyancy. No? Yesterday only we derived, no? Force of buoyancy is nothing but rho L VL G. Rho L means here, which is the liquid we are using? Water. So instead of rho L, I can write rho W, VW multiplied by G. So this is my second equation. Already here I have first equation. No? So just I want density of body divided by density of water. So if you divide these two, I will get that ratio. No? Clear? So therefore, come on, make a note up to here. So I will do the calculation here. So this is my first equation and this is my second equation. So divide both of them. So this is how much? This is 45 divided by rho WVWG is how much? It is 16.5. Okay, I got up to here. Now see. Now can you say what is meant by V here? What is this VW? V means what? V. Volume of what? Volume of body. VW? Volume of water? Displaced. VL means volume of liquid displaced. No? VW means volume of water displaced. Are you able to understand? Body is completely immersed inside water. No? Body is completely immersed. So V and VW both are equal. Volume of body is nothing but volume of water displaced. Both are same. Clear? No? So here I can say V and VW both are equal because it is completely immersed inside water. Okay. So therefore you can cancel both of them, and G values also you can cancel. So therefore density of body divided by density of water, this is called as relative density. This is also called as specific gravity, and it is equals to how much? 45 divided by 16.5. So just do that calculation. That will be our answer. Clear ma? So 45 by 16.5, 2.69. That is our answer. Okay. Right. See this question. An object floats on water with 20% of volume above the water. So what is the density of the object? So already we have yesterday derived one shortcut formula for this one. What was that formula? VL by V is equals to rho by rho L. This is the formula. No? So this is the formula we can use in which condition? When bodies are floating. In which condition? When bodies are floating. How we derived this one, that also you have remembered, no? When a body is floating, see once again I will explain. Okay, ma? When a body is floating, okay, what I can say, the force of buoyancy acting on the body and weight of the body, both of them they are equal. That's all, no? A body floats only in this condition, no? Weight is acting downwards, force of buoyancy is acting in upward direction. Only when both of them, when they get balanced with each other, then only a body can float. Clear? Force of buoyancy, rho L VL G. Weight of the body, rho V G. G and G get cancelled. So then I will get this relation. Understood, Nama? So whenever a body is floating, definitely you can write this relation. But here you should be very careful about VL. What is meant by VL here? Volume of body inside liquid. This you should not forget, ma. Volume of body outside liquid or inside liquid, that you should remember. VL means volume of body which is present inside the liquid. Now see, what is the question he gave? Object floats on water with a 20% of volume above water. 20% above means below water? 80%. So therefore, VL, I can write it as 80% means 80 by 100 into V only, no ma? V means total volume. Okay. So therefore, VL is how much? 0.8 V. This is how we write, no? 80% of total volume is present inside. 80% means 80 by 100 multiplied by V, 0.8 V. Now just substitute in this relation. So therefore, VL is 0.8 V divided by volume is, total volume is V. Density of body, I don't know. Density of water is 1000. Clear? No? So therefore, V and V get cancelled. Therefore, what is the answer I got? Density of this body is equals to 800 kg per meter cube. That is my answer. Clear now? So yesterday already we have studied another shortcut method. No? If 80% of body is present inside water, it means its density is 800. Okay, 20% of body is present inside water, then its density is 200. Like this you can remember. But that is valid only for water only. Only for water. If another liquid is given, you have to use this formula. Are you able to understand? No? That's it. Make a note. We will try to understand. Sima, see this question. So a copper cube weighs 0.5 kg in air and 0.4 kg in water. It means when the cube is completely immersed inside water, its apparent weight is 0.4. But what is its original mass? Original mass is 0.5. But when it is immersed in water, it is 0.4 only. Okay? So is the cube hollow or solid? So whether this cube, whether it is hollow or mass is completely present inside this volume, that I don't know. Okay? First of all, what is meant by cube? This is a cube, no? This is a cube. Clear, no? So whether it is completely filled with mass or is there any empty space, that I want to find out. So let us see how we can proceed. Sima, what is the actual weight of the body? Actual weight of the body is 0.5 multiplied by g. That's all, no? So 0.5 into 10 is how much? 5 kg. 5 Newton. Okay? So this is the actual weight of the body. Weight formula mg only, no? He gave in kgs. I want to multiply with the g value, then it converts into weight of the body. Okay, ma? What is the apparent weight of the body? Apparent weight. Apparent weight means what? Weight of the body when force of buoyancy is acting. Are you able to understand, ma? Or the weight which we are experiencing when it is inside water. Sima. So, when we want to lift a very big stone, we cannot lift it. But the same stone, if it is in water, you can lift it very easily. ఎప్పుడన్నా చూసినారు? ఎప్పుడన్నా స్విమ్మింగ్కి పోయినారా లేదరా న్యాచురల్గా మీరు? మీ ఫేసులు తగలయ్యే స్విమ్మింగ్ పోలేదు, చదువు రాదు, ఇంకేమొస్తుంది మీకు? సో బిగ్ స్టోన్, పెద్ద స్టోన్, వెరీ బిగ్ స్టోన్, యూ కెనాట్ లిఫ్ట్ ఇట్. But when the same stone when it is in water, you can lift it very easily. Why? Because force of buoyancy is acting, no? So the net weight of the body reduces, and that is called as apparent weight of the body. Clear, no? So apparent weight is how much? Apparent weight is 0.4 multiplied by g. So 4 Newton. Okay? So actual weight is 5 Newton, apparent weight is 4 Newton. So what happens to 1 Newton of force? Original weight is 5 Newton, but inside water it is only 4 Newton. So what happened to remaining 1 Newton of force? That it has reduced because of force of buoyancy. That's all, no? So therefore, what is the force of buoyancy? Force of buoyancy is 5 minus 4, which is equal to 1 Newton. That's all, no? Up to here it is clear, no? Okay. Now, force of buoyancy depends on what? Force of buoyancy depends on rho L VLG, no? And it is equal to 1 Newton. Are you able to understand? Force of buoyancy, rho L VLG, and it is equal to 1 Newton. Are you able to understand? Okay. Now, let us calculate, if I calculate this VL, let us see what happens first of all. Sima. VL, how can I calculate? VL is equals to 1 divided by rho L multiplied by G. Clear, no? So, 1 divided by, what is the density of liquid? Density of water is 1000. And G value is 10. Clear, no? So therefore, how much it is? It is 10 power minus 4 meter cube. Okay? Is it clear? Correct only, no? Rho L VL G is 1 Newton. VL is equals to 1 by rho L into G. 10 power minus 4 meter cube. This is the volume of this body. Which volume? This is which volume? VL means what? Volume of liquid displaced. Volume of liquid displaced, no ma? And volume of liquid displaced is nothing but? Volume of liquid displaced is nothing but actual volume of the body. Are you able to understand? Okay. So, first of all, make note up to here. Now see. So therefore, when I calculated this VL, what is this VL? This is the volume of liquid displaced by that body. Volume of liquid displaced is nothing but actual volume of the body, no? Clear, no? So therefore I can also say that VL is nothing but actual volume of the body, and it is equal to how much? And it is equals to 10 power minus 4 meter cube. That's all, Nama. Okay. Now let us take volume of body without empty spaces. Volume of body without empty spaces. Okay, ma? So how can I calculate volume of body without empty spaces? We know that density is equals to mass by volume, Nama. Density is equals to mass by volume. So what is the volume of the body without any empty spaces? Clear, no? So volume is equals to mass by density. What is the actual mass of the body? 0.5. What is the density of copper? 8.96 into 10 power 3. Okay, ma? So if I do this calculation, see how much you will get. 0.5 divided by 8.96 into 10 power 3. Calculate chest student. Scientific ga proceed avvalra problem lo. Okay, sima. So object that weighs 40 Newton in air. What is meant by 40 Newton? It means that is the actual weight of the body, no ma? So actual weight is 40 Newton. This is the meaning of this one. Okay. Sima, in air also will give some force of buoyancy. But that one we can neglect. Air is also a fluid, no? Air is also a fluid. When body is present in air also will give some force of buoyancy, but that is very less. So you can neglect it. Okay. So whenever body is in air, you can consider that is the actual weight of the body, 40 Newton. And inside water, when you submerge this one completely inside water, then it is weighing only 20 Newton. It means apparent weight inside water is how much? 20 Newton. And how I get this apparent weight? Apparent weight, how I get? Actual weight of the body. Force of buoyancy is acting in upward direction. Therefore, what is the formula for apparent weight? Apparent weight is equals to actual weight of the body minus force of buoyancy. That's all, Nama. So therefore, actual weight is 40. I want force of buoyancy now. Okay. So force of buoyancy is how much? Force of buoyancy is equals to actual weight minus apparent weight. Actual weight is 40. Apparent weight is 20. So 20 Newton is the force of buoyancy. Up to here it is clear, no? Clear, no? So therefore, when body is present inside water, how much force of buoyancy is acting on this body? 20 Newtons of force of buoyancy is acting. Why we have calculated force of buoyancy? Because in force of buoyancy only we have the formula rho L VL G. This is the formula which I have, Nama. From this I can calculate actual volume of the body. Clear, no? If I know force of buoyancy, I can calculate what is the size of the body, actual volume of the body. Okay. So actual volume of the body is how much, ma? Force of buoyancy divided by rho L into G. What is the force of buoyancy? 20. Density of liquid is water here. Water, 10 power multiplied by G. So therefore, how much it is? It is 2 into 10 power minus 3 meter cube. So this is volume of water displaced. VL is volume of water displaced, no? Volume of water displaced is nothing but total volume of the body. Because body is completely inside water, no, ma? It is completely inside water. Okay? It is immersed completely inside water. Okay? So therefore, what I can say, volume of water displaced is nothing but actual volume of the body. Okay? That is the size of the body. So once I calculated the actual size of the body, now let us go to the second condition. Okay? What is the second condition? Now when it is submerged in another liquid, okay, ma, of unknown density, then what is the weight of the body? 30 Newton. That's all, no? When we are submerging it another liquid, then its weight is 30 Newton. If weight is 30 Newton, what is the force of buoyancy? Force of buoyancy is 10 Newton, no? Clear, no, ma? Because 10 plus 30 should be equal to 40. Okay. Now again, what is the formula of force of buoyancy, ma? Again, rho L VL G. So density of liquid, I don't know. But volume of liquid displaced already I have calculated, no? Here also it is completely submerged, no, ma? ఈ లిక్విడ్లో కూడాను పూర్తిగా సబ్మర్జ్ చేస్తాం కదా. వెన్ ఇట్ ఈస్ కంప్లీట్లీ సబ్మర్జ్, వాల్యూమ్ ఆఫ్ లిక్విడ్ అండ్ యాక్చువల్ వాల్యూమ్ ఆఫ్ ద బాడీ బోత్ ఆర్ సేమ్. So therefore, again it is 2 into 10 power minus 3 multiplied by G is equal to 10. Clear? So therefore, density of liquid is 10 divided by 2 into 10 power minus 3. So multiplied by G is also there, no? Okay. So therefore, it is 500 kg per meter cube. This is my answer. Clear, no? Clear? That's very simple. Okay. Now see this question. So a piece of pure gold whose density is 19.3 gram per centimeter cube is suspected to be hollow from inside. Okay, ma? See, these jewelers, goldsmiths will be there, no, ma? Sometimes they fraud the people. Okay, so they will make some empty spaces inside the ornaments and they sell to the public. Are you able to understand? So here also there is a doubt that inside this gold jewelry there is some hollow portion, and we have to find out whether there is some hollow portion or not. Okay, let us see how we can find out. So it's suspected to be hollow from inside. It weighs 38.25 grams in air. So therefore, what is the actual weight of this gold? Mass is given, no? Actual mass is 38.250 multiplied by G. This is how I can calculate weight of the body, no? Here he gave mass of the body. Mass multiplied by G value, it converts into weight of the body. Clear, no? Here G represents grams, but here G is acceleration due to gravity. Don't be confused in that. Okay. So, and 33.865 grams in water. When this gold jewelry, when it is completely immersed in water, then what is its weight? 33.865. It means that is apparent weight, no? Apparent weight. So apparent weight is 33.865 multiplied by acceleration due to gravity. Okay. Now I will calculate two things. First, what I will calculate? I will calculate volume of gold without empty spaces. Volume of gold without empty spaces. Clear, no? So how can I calculate volume without empty spaces? Already we know density is equals to mass by volume, no? So for this particular mass, what is the volume? Volume is equal to mass by density. Okay. Mass is how much? Mass is 38.25 divided by density of gold is how much? 19.3. Okay. So 38.19, approximately 1.9 or something we will get, no? Let us see. 1.982. 1.982 centimeter cube. Everything we are writing in CGS system, no? So centimeter cube. So this is the volume of gold without any empty spaces. That means this is the raw material by which we are trying to make the gold ornament. Okay, ma? Now let us calculate what is the actual weight of this ornament, actual volume of this ornament. That one how can I calculate? From force of buoyancy only I can calculate, no, ma? Force of buoyancy is how much? Rho L VL G. And what is this VL? Volume of liquid displaced. Volume of liquid displaced is nothing but actual volume of that gold ornament. Okay. And force of buoyancy, if I subtract these two, I will get force of buoyancy, no? Clear, no? So therefore 38.25 multiplied by G minus 33.865 multiplied by G is equals to rho L VL into G. Okay. So G and get cancelled. So therefore volume of liquid displaced is nothing but actual volume of the ornament. This is equals to 38.25 minus 33.865 divided by density of liquid. Okay. Here liquid is water only, no? So therefore 38.25 minus 33.865 will be how much? 4.385. Okay, ma? So 4.385 divided by density of liquid is how much? 1000. Okay, ma? So actual volume how much I got? So here, see ma, everything we are taking in CGS system, no? So density of water in CGS system is only 1 ma. Okay. In SI system it is 1000, but it is in CGS system density of water is how much? 1 gram per centimeter cube. So therefore 4.385 centimeter cube. Okay. What is this 4.385 centimeter cube? This is the actual volume of gold ornament. But for the same mass, what should be the volume if there is no empty spaces? 1.982. But actual volume is much greater, no? It means in this ornament, definitely empty spaces are present. That is the meaning of it. Clear, no? So therefore, how can I calculate the volume of empty spaces? Volume of empty space is equal to 4.385 minus, how much more? 1.982. If you do this calculation, whatever answer I will get, that will be my, how much more? 4, no, 2.403. 4 minus 2, no? 4 minus 2, approximately 2 point something you will get. 2.403 centimeter cube. 2.403 centimeter cube. That is my answer. Clear? So let us see this question, ma. So a cube of wood floating in water supports a 200 gram mass at the center of its top face. Okay, ma? Now first of all, let us draw the diagram of this particular question, ma. So consider this is a cube. Okay, ma? So on this cube, we are placing another mass. That is the question, no? Supports a 200 gram mass. So this is a 200 gram mass. Clear, no? So, and this cube is floating on the surface of water. So this is the given question. Okay, no? So question is that when the mass is removed, when I remove this mass, I see that a cube rises upwards by 2 centimeters. Clear, no? When mass is present, it was floating. But when I remove this 200 gram mass, we see that the cube is moving upwards by 2 centimeters. First of all, can you say, when I remove this mass, why this cube has moved upwards? Explain it exactly. Huh? Okay, we will try to understand in one more method. So if I remove 200 gram mass, it will move upwards. It means if I place 200 grams mass, it will move downwards. Why it is moving downwards? మనం దేంతో వింటామంటే చెవులతో నోటితో ఇదిగా చెప్పాల్సి చెవు లోపల ఇయర్ డ్రమ్ ఉంటుంది దాంతో వింటాము అని చెప్పాలి. వెయిట్ పెట్టాం కాబట్టి లోపలికి పెంచారు మాకు తెలుసు అది. వై ఇట్ మూవ్ డౌన్వర్డ్స్? Sima, if I place a 200 gram mass, this cube should support this mass, no? Now in addition to cube, mass also should float, no? In addition to cube, mass also should float on the surface of water. Floating when it is possible, floating is possible only when weight of the body is equal to force of buoyancy. That's all, no? Is it correct? So bodies will float in wind condition. Bodies will float in which condition, ma? When, okay, weight of the body is equal to force of buoyancy. That's all, no? Okay, and force of buoyancy is provided by whom? Force of buoyancy is provided by volume of liquid displaced by that body, VL. Clear, no? So if more volume of liquid is displaced, the water will give more force of buoyancy. Is it correct? So therefore, what is the another note point here? We have to write another note point is that force of buoyancy depends on what? Force of buoyancy depends on volume of liquid displaced. Volume of liquid displaced. Okay, ma? So if more volume of liquid is displaced, more force of buoyancy will be present. That's all, no? So if I place this 200 grams body on this cube, and force of buoyancy should increase, no, ma? How force of buoyancy will increase? This cube will go downwards. Initially, only some of the cube was floating. Some of it was inside. When I place this 200 gram mass, cube will go down. Why cube goes down? So that it can displace more water. Okay? If it displaces more water, more force of buoyancy will act. So that this 200 grams also can float on the surface of water. That is the meaning of it. Are you able to understand what is happening? So therefore what we write? Therefore we write, when 200 grams mass is placed on water, we are not discussing about removing mass. We are discussing in opposite sense so that you can understand. When 200 grams mass is placed on cube, cube goes down. Cube goes down. Why it goes down? So that more water is displaced. So that more water is displaced. If more water is displaced, what happens to force of buoyancy? Force of buoyancy increases. Clear number? So that force of buoyancy increases. Why force of buoyancy should increase, ma? Because previously force of buoyancy was supporting only this cube only, no? Now force of buoyancy should support 200 gram mass body also. Therefore force of buoyancy must increase. Okay, now we will discuss about the actual problem. Now when I remove this 200 grams mass, what happens? Again this cube comes upwards. Why? Because now that much force of buoyancy is not necessary, no? So cube moves upwards. Is it clear, ma? Therefore what I can say, therefore additional water displaced provides additional force of buoyancy. Clear, no? When cube goes down, okay, ma, more water it will displace. If it displaces more water, it provides more force of buoyancy. Arthamatunda logic? Clear, no? Therefore, weight of additional displaced water. This balances weight of 200 grams mass. Can I write like this? Okay, ma? So if cube goes down, it provides additional force of buoyancy, no? That additional force of buoyancy is responsible for balancing the weight of the body. And force of buoyancy is nothing but weight of liquid displaced, no? Archimedes principle. Force of buoyancy is equal to what? Weight of liquid displaced. So weight of additional liquid displaced is balancing the additional weight which we have put. What is that additional weight? Weight of 200 grams body. Is it clear? Okay. Now can you say what is the additional water displaced, ma? Can you say? Additional water displaced is how much? When I place this cube or when I remove this cube was moving upwards by 2 centimeter, no? Clear? So therefore what is the volume of liquid displaced? Additional volume of liquid displaced. How can I say? Volume of liquid displaced, I can write like this. Sima. This is a cube, no? Cube. Cube means length is A. Breadth is also A. Thickness is also A only, no? So therefore, additional volume of water displaced, can I write, okay, ma, is equals to area of cross section multiplied by 2 centimeters. Can I write like this, ma? Volume is length into breadth into height only, no? Okay. So for example, see, I will draw a 3-dimensional figure. Okay, ma? So this is length, A. This is width, A. A into A, area. Length into breadth will give area, no? Area. Area multiplied by how much height is displaced additionally? 2 centimeter. Area multiplied by 2 centimeter? Volume. That's all, no? So therefore, additional volume of liquid displaced is area of cross section multiplied by 2 centimeter. So I got volume of water displaced, no? So substitute in that equation. Okay, ma? Completed? Okay. Therefore, okay, weight of liquid displaced, additional weight of liquid displaced, weight formula rho L VL G. Force of buoyancy only, no? This is equals to weight of 200 grams mass. So 200 multiplied by G. That's all, no? Mass is 200. If I multiply by G, it converts into weight of the body. Okay. Additional weight of liquid displaced is nothing but force of buoyancy. Additional force of buoyancy. Additional force of buoyancy formula, rho L VL G. Rho L is nothing but density of liquid. Density of liquid is 1 in CGS system. Clear? Volume of liquid displaced already I have calculated. How much? A into 2. Okay. This is equals to 200 multiplied by G value I forgot to multiply, no? Multiplied by G is equal to 200 into G. So G and G if you get cancelled. Clear nama? So density volume A into 2 multiplied by G is equal to 200. Okay. So A value is how much? A value is 100 centimeter. Okay. A can be written as L square, no? Or A square I can write, no? A means area, no? Ma? Area can be written as A square. So therefore what is A value? Therefore A value is 10 centimeter. Clear, no? So therefore what is the length of this cube? 10 centimeter. Breadth of the cube? 10 centimeter. Height of the cube? 10 centimeter. So therefore what is the volume of the cube? A cube. Volume of the cube only he is asking. Therefore volume of cube is how much? Volume of cube is equal to A cube. So 10 power 3 is 1000 centimeter cube. So that is the volume of this cube. That is how we have calculated. Are you able to understand how we have done? Okay. So very simple concept. Concept is based on what? Concept is based on that if you place additional mass, cube should go additionally 2 centimeters downwards, so that more water is displaced. If more water is displaced, more force of buoyancy. And what is that additional force of buoyancy doing? It is balancing this 200 gram mass. So additional force of buoyancy is nothing but weight of the additional mass. And VL, volume of liquid displaced, means additional volume of liquid displaced. I can calculate by using this technique, no? Area multiplied by the thickness, the height which is going inside. Area multiplied by height. That is the volume of cube going down, no? And that is the volume of liquid displaced also. Is it clear? Cube లోపలికి ఎంత పోతుందో అంతే additional water displace అయి ఉంటుంది కదా. That's it. Have you understood?